Did you know that the Earth's surface is about 510 million kilometres squared? This is quite a large number, but there's another way to express this. We can write it in what's called standard form. It looks like this. Here we have the number in standard form. To write a number in standard form, place a decimal point between the first and second significant figures. This will always give you a number between 1 and 10. That's at least 1, but less than 10. Once we've got this number, we need to work out how many times we need to multiply it by 10 to get to the ordinary number. Well, let's count the number of digits there are after the 5 here. There's 1, 2, 3, 4, 5, 6, 7, 8. That's where our 8 comes from. This number here tells us how many times to multiply 5.1 by 10 to get 510 million. 10 to the power of 8 looks like this. If we take 5.1 and multiply it by 10 to the power of 8, we should have a 5 and then 1, 2, 3, 4, 5, 6, 7, 8 digits after it. Let's check again. The 5, 1, 2, 3, 4, 5, 6, 7, 8 digits after it. Standard form is really useful for writing large numbers in a more concise way. A certain virus is 0.00000000024 centimetres in diameter. That's a really small number. Now we can use standard form to represent small numbers as well as large numbers like this. Here, 2.4 multiplied by 10 to the power of negative 10 is equal to this small number here. How do we do it? We place the decimal point between the first and second most significant figures. And that always gives us a number between 1 and 10. That's at least 1, but less than 10. Here we have 2.4. And now I want to work out how many times I need to divide by 10 to get the original ordinary number. And to do that, I can count the zeros that come before it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's where this negative 10 comes from. And it's because in my answer, the 2 starts before the decimal point, but the original one, it's moved from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places to the right. That's why the negative 10 is there. 10 to the power of negative 10. Let's consider that for a moment. This is 1 divided by 10 to the power of 10, which is this. This is why when we multiply 2.4 by 10 to the minus 10, we end up with a really small number. It has the same effect as dividing by this number here. Let's write each of these numbers in standard form. 4,000, we put the point between the first and second most significant number. This becomes 4.0, or just 4 is fine. Multiplied by 10 to the power of 1, 2, 3. This number here, we put the decimal point between the first and second most significant figure. Now notice there's an 8. They're not all zeros, so we're going to leave that 8 in there as well so that it can become 8,000. Multiplied by 10, how many times? 1, 2, 3, 4, 5 times. We put the decimal point between the first and second most significant figure. So that's this one and this one. 5.6 multiplied by 10 to the minus this time, negative 1, 2, 3, 4. Here, 1 is the most significant. We put the 0, 7 there this time. And we're going to multiply that by 10 to the power of negative 1, 2, 3, 4. Let's do it the other way this time. These numbers are in standard form. Let's write them as ordinary numbers. 5 times 10 to the 3, well, 10 to the 3 equals 1,000. So we're going to end up with 5,000. I like to do it like this. 5 goes first, the 2 goes next to it. The 10 to the 3 tells me I need 1, 2, 3 numbers after the first digit. So these have to be zeros. Here's the next one. 9, 0, 5, 8. I want 7 numbers after the 9. 1, 2, 3, 4, 5, 6, 7. These have to be zeros. Going the other way. This time, because it's negative, I know it's going to start with 0 point something. And this number here tells us the number of zeros before we get to the 4. So 1, 2, 3, 4, 5. And then I'm going to write a 4 and a 3. Here's the next one. It's negative, so I know it's got to start with 0 point something. And this number here tells me the number of zeros before I get to the 7. 1, 2, 3. And then I've got 7, 6, 0, 4. Sometimes we get asked to do calculations in standard form without a calculator. My advice is to turn it into an ordinary number first, then do the calculation, then put it back into standard form, like follows. Here we have the answer in standard form. One more question. Here we have a division with standard form. Well, this time, instead of writing out the numbers in full, I'm going to use what I know about division and factors to solve this. This is the same as 8.2 over 4.1 multiplied by 10 to the power of 12 over 10 to the power of 5. Well, I can simplify this fraction because I notice that 4.1 goes into 8.2 2 times. And here, 10 to the power of 12 divided by 10 to the power of 5 is the same as 10 to the power of 12 minus 5. So my final answer is 2 multiplied by 10 to the 7.